Okay, let's do a 4 by 4 determinant. Um, so here it is. Uh, and let me remind you, one way to do this, and this isn't the way that I'm going to do it, but on the final, I'm not going to specify any method, so you can do it this way if you want to. Um, you can expand along a row or a column. So here I showed how to expand it along the first row. Of course, if you're going to do this, it would be smart to pick a row or a column that has a lot of zeros. Of course, this matrix doesn't have any zeros, so um, we're out of luck. But we can still do this method. It's just not going to be that easy. So what you do is that there's a plus minus checkerboard pattern. So and the top left is a plus. So I'm going to start with a plus, and then from there it goes plus minus plus minus. Other than that, you do whatever the entry is. So the first entry is a 1, and then you multiply it by the determinant that you get by just covering up this and this. And then you would keep going. The next entry is a 3. It has a minus from the checkerboard pattern, and then you would multiply that by the determinant that you get from covering up this and this, and so on. And you can do it this way. Unfortunately, you have to do 4 3 by 3 determinants, so that's kind of a mess, but it will work. So let me show you the other way, elimination. I would like to do matrix operations to make this an upper triangular matrix, and then the determinant would just be the product of the diagonal entries. So let's try to do that. Basically, I'm trying to get this matrix in echelon form. Some of the operations I do will not change the determinant, and other ones might. So let's see how this goes. I would like to do row 2 minus row 1 to get a 0 there, row 3 plus row 1 to get a 0 there, row 4 minus 2 row 1 to get a 0 there. These are all operations that do not change the determinant. Adding or multiplying a row to another row, adding a multiple of one row to another row does not change the determinant. So row 1 stays, row 2 is now 0, 1, 1, 1. Row 3 is now 0, 1, 2, 0. And row 4 is now 0, 0, 2, 10. Right? Now, I would like to, I have a 1 here. I would like a 0 here. So I can do row 3 minus row 2. And again, this is an operation that doesn't change the determinant. Zero, 0, 1, negative 1. Yeah, and then I'm almost there. I'm almost at an upper triangular matrix. The only thing that's bothering me is this. So I can do row 4 minus 2 row 3 to get rid of that. So I'm like that. This, and then 0, 0, 0, 12. And then the determinant is the product of the diagonal entries. So I just get 12. Yeah, so by the way, well, I mean, we're done, but if I had switched two rows of the matrix, like switched two places, that would have the effect of switching the sign. So I could do that operation, but then I would write negative of whatever the new determinant was. I could also multiply or divide a row by a number, and that has the effect of multiplying the determinant by that same number. So if you do that, then you have to fix it by dividing by that number. Um, so those are the two operations you have to watch out for. And in this one, we only did operations that didn't change the determinant, which is usually that's most of the operations that you're going to do when you do this. Anyway, let me stop recording and then do an inverse.